Hello everyone. In this video, I'm going to explain about methods of transistor biasing. There are four methods of transistor biasing. So first one is fixed bias or also called as base resistor method, and fixed bias with emitter resistor, collector to base bias or also called as biasing with feedback resistor, and then we have voltage divider bias or also called as self bias. In this video, I'm going to explain about fixed bias or also called as base resistor method. So just observe the circuit for a while. So we have an AC input signal which is given to the coupling capacitor C1. So this coupling capacitor C1 is connected to the transistor. So we have three terminal in the transistor. One is base, emitter and then collector. And then we have the base resistor RB which is connected to the base. And IB is the current flowing through the resistance RB. And we have a resistance RC which is connected to the collector, and IC is the current flowing through the resistor RC. And in the output, we have the coupling capacitor 2 which is connected to the output signal. Now, the emitter is grounded here. So to analyze the circuit, first we have to consider the base emitter loop. So we have to apply KVL to the base emitter loop. So if we apply KVL to the base emitter loop, we will get VCC minus IBRB minus VB is equal to 0. So we'll get, when we apply KVL in the clockwise direction to the base emitter loop, we will get VCC minus IBRB minus VB is equal to 0. So I'm just bringing this IBRB that side. Then this minus will become plus. So IBRB which is equal to VCC minus VBE. So from this equation we can obtain IB. IB is equal to VCC minus VB divided by RB. So if we apply KVL to the base emitter loop, we can obtain the base current IB. Similarly, we have to consider the collector emitter loop. So this is the collector emitter loop. So if we apply KVL in the clockwise direction to the collector emitter loop, we will get an equation as plus VCE plus IC into RC and then minus VCC is equal to 0. So from this equation, you can get, if you apply KVL in the clockwise direction, you will get VCE plus IC into RC minus VCC is equal to 0. So from this equation, we can obtain the collector emitter voltage VCE. So VCE is equal to VCC minus IC into RC. Now, the magnitude of collector current is related directly to IB through IC is equal to beta into IB. IC is the collector current and IB is the base current. So the relationship between the collector current and base current is IC is equal to beta into IB. So beta is nothing but the transistor current gain. Now we have to find the stability factor of fixed bias. So the general formula for the stability factor is given by S is equal to 1 plus beta divided by 1 minus beta into dou IB by dou IC. Now we have got IB equation from applying KVL to the base emitter loop. So already we have got the equation as IB is equal to VCC minus VB divided by RB. So here IB is completely independent of IC. So if we differentiate IB with respect to IC, we will get 0. So if you substitute dou IB by dou IC is equal to 0, the remaining equation what we will get is S is equal to 1 plus beta divided by 1 minus beta into 0. That is 1 plus beta. So we have obtained the stability factor S. Now we have to find the stability factor S dash. So S dash is given by dou IC divided by dou VBE. VBE is the base emitter voltage and where your ICO and then beta is constant. So already we know IB but we don't know IC, right? So what is the relationship between IB and IC? So IC is equal to beta into IB. So from this expression, we can obtain IB, right? So IB is equal to IC divided by beta. So instead of IB, we have to substitute IC divided by beta. So I'm just taking this beta that side. So IC is equal to beta into VCC minus VB divided by RB. So I'm just rewriting this equation as beta into VCC divided by RB minus beta into VB divided by RB. Now I have to differentiate, right? So if you differentiate this equation with respect to beta, so this term is independent of VB. So if we differentiate, we'll get 0. And if we differentiate this term in terms of VB, what we will get? Minus beta by RB. So dou IC divided by dou VBE can be written as S dash, which is given by minus beta by RB. Now we have obtained the stability factor S dash. Again, we have to find the stability factor S double dash. So S double dash is given by dou IC divided by dou beta, where VBE and ICO is constant. So we have to differentiate IC with respect to beta. So already we have obtained an equation IC, right? So IC is equal to beta into VCC minus VB divided by RB. So if we differentiate this equation with respect to beta, what we will get? VCC minus VB divided by RB. So which is nothing but what? This is the IB equation. So we can write dou IC divided by dou beta as IB. What is IB? IC by beta. And then we have got the stability factor S double dash also for the fixed bias. Thanks for watching.